Hello, everyone. So this is section 2.7. And this section, I will be basically talking about a little bit of physics things and a problem related with physics. Uh, the, basically, it's physics and calculus both, combining physics and calculus both. Okay, so I will just do a quick review of what you learn in physics. I don't know if you guys have uh, taken any physics class yet, but um, yeah, I'll just do a quick review of the physics things. So basically here, the physics, or basically here in this class, not in physics, in this class, um, uh, so, or in this section, you will be given uh, a function, something like this, S function, which is, this function is called, basically this function is called, um, is a position function, or this one we can also simply think like a displacement or maybe a distance, something similar to this. If you guys have taken the physics class, maybe you will get it. But even if you haven't taken the physics class, not to worry. I'm not really going to go too much deep into physics, but I'll be still focusing on calculus thing. All right. It's just that we need few things from physics. Okay. And then, this function will be given actually on the problems that you'll be doing in this section. This function will be given. So like I said, this is a position functions. And from this function, you can find um, the velocity. Or we can even say this V. Okay, so we can find the velocity from this position function if I can take the derivative of this function, of this position function. So if I take the derivative of this function, since we are saying this function is s, so if I take the derivative of that function, it will be ds over d, what are you gonna get here in the denominator? Do you get x or t? It's t, right? Because since we are saying this s is in terms of t, so we are taking the derivative of s in terms of t. Okay, or simply we can write s prime as well, right? So the derivative of this is s prime. And the unit or the way we denote the velocity is basically when you're working on an actual problem, your answer should be some number and meter per second. So basically it is saying velocity means you cover some distance in some seconds or within some times, right? So that's how it is written, meter per second. And here, this one is, well, since we're saying this is distance, so the way we write it is just m, which means meter. And after that, now you can get acceleration from this v. So we can get that, or we can even write acceleration as a. So if I take the derivative of this v, again in terms of t, then this is called acceleration, or even we can write, since dv over dt is also basically, since we are taking the derivative of this function, so we can simply write v prime, or we can even write this as, since we're taking the derivative of this s function twice, so we can write s double prime. So we can say, well, this means we're taking the derivative of this s two times, right? Let's do some examples related to these things. But before I start doing the examples, I want to explain one more thing. Okay, so you need to know this idea first, and then after that, okay, let's say some person, let's say a person throw a ball in a vertical direction or vertical motion. Okay, so that means a person will throw a ball with in some speed. So the initial speed will be if you're throwing a ball in a vertical direction, you'll use some speed, right? So that speed will be, let's say, vi, or this means v initial. You'll be given this. Okay, so you'll see that in the actual problem most of the time. And the thing is, once you throw the ball, it will reach to a certain height or to a maximum height, right? So once it reaches to the maximum height, it will stop there for a few milliseconds or for a few seconds, right? So at that time, or at the maximum point, the velocity is going to be 0, right? You'll throw the ball upward in vertical direction, and when it reaches to the maximum height, then it will stop for a few moment or a few seconds or a few milliseconds. And then once it reaches the maximum height, then it will come down, right? And after that, you will get the final velocity, right? So here, the main idea I want to talk is this. When it reaches to the maximum height, the velocity is 0. Okay? So we will be using this concept later on in the problems. Okay, so let's start doing the problems then. Okay, so here, the height of projectile motions are vertically upward for 0.2 meter above from the ground level with initial velocity. Okay, so initial velocity, like I said, here, this initial velocity is given, all right? But anyway, find the velocity after 2 seconds. Okay, so here, h is equals to this thing, all right? So now this is, well, since we're saying the height of blah, 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 blah with this h is equals to, this means the height in meter. So when you see in meter, that means this function is basically this whole function. You can take this as a position function. All right. And then after this, now we are trying to find the velocity after 2 seconds. All right. So we are trying to find the velocities. So since we have position function, so like I explained here, if you have a position function, then you can find the velocity function. If I take the derivative of that. So let's do that first. So let's find the velocity first, or velocity function first, and then after that I can find the velocity after 2 seconds. All right, so let's find the velocity. V is equals to, I'm taking the derivative of this function, right, or dh over dt, which is, now if I take the derivative of this, well, when you take the derivative of this number, it's 0, so you don't have to write that. When you take the derivative of this, well, 24.5, stay there. Now you're taking the derivative of just t in terms of t, so dt over dt is just 1. Right, so this is basically, I talked about this on previous lecture videos, right? And then here, okay, this number will stay there, and you're taking the derivative of t square. So in this one, you can use power rule, so you can bring this 2 down here, and then the new power will be t to the power 2 minus 1, which is just 1, so you don't have to write that. Or basically, it's multiplication here, right? So 4.9 times 2 is, this is v function, right? So v is equals to 24.5 minus 9.8t. All right, so this here you get a velocity function, and then after this, you're finding the velocity after 2 seconds. So that means the t here, it means second, right? Okay, so since we're saying the t is 2 seconds, so you can just plug this in value here to get the velocity after 2 seconds. So let's write v after 2 seconds is equals to, from here, 24.5 minus 9.8 times 2, right? So and then after this, you get, okay, use your calculator and you'll get 4.9. And then 4.9, like I said here, when you're working with velocity, or when you found the velocity, that means the velocity should be the unit of this is called unit. So whatever number you get, that number and the unit. So this means 4.9 meter per second. All right, so you have to write this in the exam. Okay, so if you just write a number, it doesn't make sense. When you write this, well, it will show that, okay, you're talking about velocity. Meter per second means it's a velocity. Okay. Now let's go to the next one. Okay, so now, again, same thing. Now this is part B. So here now you're finding when does the projectile reach, or basically this thing reach its maximum height. So we are finding at what time, or we're finding the time at what time it will reach the maximum height. So as I said, it will reach the maximum height when we can say the velocity is 0, right? Since we already found the velocity function, so from this function, if I say v is equals to 0, right? I said that v must be 0 at the maximum point, right? So that means at the maximum height, v is 0, right? And the v value, we just said that the v is this, right? 24.5 minus 9.8 t is equals to 0. Now move this to other side, negative 9.8 t is equals to negative 24.5, and then divide negative 9.8 on both sides, so negative gone, so the t is 2.5 seconds. All right, so again, you have to write the unit. This is also the unit of the time. Or you can simply write S. You don't have to write SECS. Or just simply write S. Okay, so now after this, what is the maximum height? Okay, so since we found the time it takes to reach the maximum height, now what exactly is the maximum height? So now to find that, well, we can simply now take we can simply take this equation, which is the position equation, and then plug in the value of t that we got here. So since we're saying at this time it will reach the maximum height, so when we take this value to the actual position equation, then we can find the maximum height value. All right, so now since we know the position function is 2 plus 24.5 t minus 4.9 t square. Okay, now just plug in this value here. So 2 plus 24.5 times t is again 2.5 minus 4.9, 2.5 square. And then again, okay, you just do that by yourself, the calculation part, and then I'll just give you the final answer. So this is 32.625. All right, so since we are working with the height, so that means our unit here is going to be what? It's going to be meter, right? This is not velocity, this is not acceleration, this is height, right? So height means it will be meter, right? Okay, now after this, when does it hit the ground? So what time it takes to hit the ground? Okay. So how do we find when does it hit the ground? So the way we find that is, well, from the the position. Oops, 24.5. 4.9 t squared, right? So when does it hit the ground? So that when the ball hit the ground, so that means this position or the distance is basically it's zero, right? So when you hit the ball, basically this function is, well, basically defines at what position the ball is when in certain time. But since we were saying the ball is in the ground, so how long is it going to take? So to find that, the h is going to be zero. So because since we throw the ball from here and it returns here, so that means there is no change in the height, right? So that's why the height is zero, or h is zero. So basically in the homework, you'll probably see a similar problem. So if you understand the idea I'm explaining here, you should do fine in the homework. You should be able to do the homework. It shouldn't be two problems. Um, so okay, now once you get this one, now when does it hit the ground means we are finding the time, right? Point means we are finding the time. So to find that, now since we know this is equals to zero, so since we have t squared, so this is a quadratic function, right? So if you remember what you did in algebra, so x squared plus bx plus c is equals to zero is basically a quadratic form, or since we have t here instead of x, so I can just say a times t squared plus b times t plus c is equals to zero. And then now when you compare this, we can find ABC, right? The value of ABC. And then from that means A is, well, it's A is the coefficient of t squared, which is basically negative 4.9. B is the coefficient of t, which is 24.5. Right, and the C is 2. All right, so once you get that, now, well, here I'm trying to use a quadratic formula. Okay, so quadratic formula here is, do you remember what is the quadratic formula? So quadratic formula is t is equal to negative b plus minus square root of b squared minus 4ac over 2a, right? Okay, so now after that, well, just plug in those values here, all right? Well, and then when you do that, you should get negative 24.5 plus minus, right? Because we have plus minus here, and then from here, you should get 25. It's 7 over negative 9.8. Well, the reason I'm skipping this is, well, I want you guys to do this by yourself and figure it out. It's not hard, you know. It's just the algebra stuff. I'm pretty sure that you guys will be able to do it. It's just that you have to work with the numbers. I've given you the value. Just plug in this value here and get this number. All right, so it shouldn't be too hard. Now, since we have plus minus, Now let's just take the plus first and then, excuse me. Okay, so that means, well, this is t. So when you take the plus, t is equal to negative 24.5. Oops, it's not clear. 24.5 plus 25.287 over negative 9.8. So again, from here, t, you'll get negative something. All right. And here, another one, when you take a negative, so you get negative 24.5, negative 25.287 over negative 9.8. So again, from here you'll get positive 5.08 second. Now here, since here you get negative something, well, when you're working with the time cannot be negative. All right. So I don't think you have ever heard, okay, it took me like negative 2 hours to do something, right? That's not possible, because that's why we say time cannot be negative. So it is just t is this value, 5.08. Okay, now after this, once you find the value of t, now we have with what velocity does it hit the ground? Okay, so we are finding the velocity when it hit the ground. Okay, so since we know that it takes this much time to hit the ground, so if I can take this t value and plug in this t value to the velocity function, then I can find the velocity it takes to hit the ground, right? So the velocity function we have here is this one, right? Yeah, this one, right? 24.5 minus 9.8 t. So then 24.5 minus 9.8 t. Plug in this t value here. Well, this t value here, then 24.5 minus 9.8 t is 5.08. Now here, velocity we get is negative 25.284, and the unit here is, since we said it's velocity, so the unit is meter per second. And here the velocity can be negative, all right? Velocity can be negative. The reason that we have negative here is it is, well, since we throw the ball and it is coming down, so it's in the opposite direction. So that's why we're negative here. It's coming, it's opposite to this direction, right? This is going upward and this is opposite to this direction. That's why the velocity is negative. Okay, now let's do another example. So now this is another problem. We have a new function here. Now here we have s, h doesn't matter. The position of a particle is given by the equation this, where t is the time and s is the meter. Right. Now again, this is a position function. As I said, the s is in the meter. Now find the velocity at time t, certain time. So it's just that we need to take the derivative of this function. All right, so we can find the velocity when you take the derivative of s in terms of t. The reason I have t here is, again, this function is in terms of t, right? And then after that, I can take the velocity of the derivative of this. So when I take the derivative of this t cube, 3 come down here, and then the new power of this t is going to be t to the power 3 minus 1 minus, again, 9 is there, and then the 2 is going to come down, and then again the new power is 2 minus 1 plus 24 t is simply just 24, right? Because when you take the derivative of t, it is just 1. Okay, then we get v is equals to 3t squared minus 9 times 2 is 18 t plus 24. Okay, and then after this, now we need to find the velocity after 1 second. So since already we found the velocity function here, then just take that this value 1 here. This is similar to another example, the first example I did. It's just that you have to plug in this value here, and then you get the velocity at this second or after this second. Now, it's 3 times 1 square minus 18 times 1 plus 24, and then you get, okay, again, do that calculation part, and then you'll get 9. Again, since you're finding the velocity, so it's 9 meters per second. Okay, and then after that, when is the particle at rest? Okay, so when do you think the particle is going to be rest? When the velocity is 0, right? When the velocity is 0, so from the velocity function we found here, so we're saying the velocity is 0, it's v is 0, so that means on the left hand side 0 is equals to this function, right? So 0 is equals to 3t squared minus 18t plus 24. Again, it's similar to the first example I did. So again, the quadratic function is equals to 0, then we can simply use this quadratic formula, or we can also do this without using quadratic formula. Let's factor out 3 from all of this, right? Because it seems like 3 is a common, so let's just factor out. So when I factor out 3, t squared minus 6t, right? And then just divide 3 on both sides, so we simply get t squared minus 6t plus 8 is equals to 0. So since we have 8 times 1, which is 8, so 8 times 1 is 8, 4 times 2 is 8. So it looks like I can use 4 times 2 is 8. It looks like I can use 4 and 2 because we have 6 in the middle, right? Because -4, -2 will give 6. All right, so that means I get t minus 4 and t minus 2, because -4, -2 will give -6, right? Or if you still find difficult using this process, you can still use quadratic formula just like I did here. Okay, but yeah, you should get the same answer. Okay, and then after this, here it's either t is equals to 4 or t is equals to 2. And here we got two value of time where the particle is in the rest. So that means probably basically it looks like the motion is something like this. Okay, so basically maybe it's a ball, it's bouncing 2-3 times, something like this. So that's why we got the time 2 times, or 2 value of time where the particle is in the rest. So at this point it's in the rest, or at this point, something like that. Okay, it's not exact picture, but it's something like that. And now when is the particle moving in the positive direction? Okay, so in the positive directions means so when the particle is moving in the positive direction. So here this means the velocity is positive. So velocity is positive means it should be greater than 0. Okay. So now again, the velocity function we have is, from here we have the velocity function is 3t squared minus 18t plus 24 is greater than or equals to 0. And again, from here, since we already found this part here, right? So the factor of this 3t squared minus 18t plus 24, we already found that here. So we can just simply write that t minus 4, t minus 2 is greater than 0. Okay, so now here, we are trying to find when is the particle moving in the positive direction. So here we are finding the value of, we're just basically finding not just one value of t, we're finding the value that is possible more than one times. All right, so here again, this is again the concept I think you learned this in algebra. I'm pretty sure you guys learned this in algebra, but again, I'll explain that here. So basically when we have f of x, where f of x is a quadratic equation, so since we have a quadratic equation here, if f of x is greater than 0, and then from here, if we get some value, so here we get t4 and t2, let me just write t1, t2. And when we get f of x or a quadratic function greater than 0, that means our positive direction is going to be in this region or in this region. Okay, and when we have f of x or quadratic form, quadratic equation less than 0, and again, if we get something similar, the time something similar to this, then our answer is going to be this middle region. Okay, so since here in our case, let me just erase this, we don't need that here. Since in our case, now we found, and since again, if you're working with the equal sign, you just get one value or maybe something like this. But since you're working with inequality, our answer is not just going to be one value, it's just going to be a whole region. So to find that region, it's again similar concept I explained here. So since we found t4, so let's say 4 is going to be here and 2 is going to be here, right? When you go to from left to right, you get small value first and then the largest value after that. Okay, now again, like I said, since we have greater than, so that means it's going to be this region. So at this region, the particle is moving in the positive direction. So here, if you go to the left-hand side, it's going to the negative infinity. If it goes to the positive side, it is going to positive infinity. So that means when you write this in interval notation, or simply you can say that it is positive when t is, well, t is less than 2, right? Because this region is less than 2 region, right? Or t is greater than 4. Okay, so that's the answer. Well, this is the answer of, oops. This is the answer of, these two are the answer of this questions, this problem. When is the particle moving in the positive directions? At this time, it is moving in the positive direction, all right? Now, after this, okay, finally, we are working with the acceleration. So find the acceleration at time t. Okay, so again, the acceleration, we find the acceleration, or a, when we take the derivative of v, right? So since we know the v is this, let me just write v here. V is 3t square minus 18t plus 24, right? So now a acceleration is, here I need to take the derivative of this. So again, 3 times, we'll bring this to here, so 2 to the power 2 minus 1, which is just 1, minus 18t. When you take the derivative of 18t, it's just going to be negative 18, right? And the derivative of just the number is 0, right? And then this is simply 3 times 2 is 6. Okay, so 60 minus 18. And then after that, you also need to find or we need to find the acceleration after 1 second. So since we already found the acceleration equation, and now we can find the acceleration after 1 second. If you just plug this in here, so it will be 6 times 1 minus 18, so it is negative 12. And the unit here is the unit of the acceleration is meter per second square, right? So for acceleration, it's this one. For velocity, it's meter per second. And for the distance or for the position, it's just meter. Okay, so that's all I want to talk from this section. Okay, and make sure you do the wave assign homework. The wave assign homework. Like I said, the wave assign homework. I think I've sent an email. You can see this in the Blackboard announcement as well. 2.3, 2.4, and 2.5, 2.6. The due for this homework is going to be this coming Saturday. Saturday, which is September 19. Yeah, midnight, 11:59 p.m. And this section is since section 2.7, so I'll make the due for this one the week after this. Okay. Anyway, I'll see you in the next video. Thank you.